Now let's build the controller for stops. We've gone through and seen how to create a controller for an API, so a lot of this is going to be applying those same ideas towards a related controller. So let's add a new class called stop controller. Like before, we'll derive it from controller. I'll create a constructor that accepts both a world repository, so we can save data, and an iLogger for the stop controller, so we can use the log as well. Let's refactor both of those into existence, and we've now got the beginning for a basic controller. Let's go ahead and implement the get method. I'll just mock that up so it's a complete method, and let's talk about that. In our last controller, we used a route attribute to specify the basic route for the entire class. We're going to do that again. So API is certainly where we're going to start, and I could do stops and do the same sort of thing that we did with trips and have a immediate endpoint for just querying stops. We might need to supply some different things. But more interesting for us is that we probably want, when we design this API, to have the API show stops in the context of a trip. So if you remember the other API, the other route started with API trips. So we're going to start ours with trip, except that we're going to use a parameter. Now inside the route string here, we can use curly braces to represent a replaceable object. You could imagine something like ID, but in our case, this is going to be the trip name. So when someone goes and wants to look up an individual trip, we could have implemented, and we haven't, but we could have implemented to look up trips, trip name, as a parameter directly on the trip controller. But for us, what we want to do is allow them to go and look at the stops of a particular trip. So we're going to describe this API in a way that's going to make sense, because it's like walking down the tree from trips down to stops. This implies something though. How do we get this parameter name passed in? Some of you are probably already ahead of me and know that means we need to supply the trip name as a parameter to the method. Since we want to implement get here, we'll use get, and we'll use an empty route again because we're going to inherit or derive from the route up here. It's going to end up using the same URI. And what we're going to want to do is get the results of the trips to return. So let's use that repository. And we don't have a method for get trip by name, so let's add that, passing in our trip name. Now for us, we're going to use a try catch to make sure that we don't get anything bad happening. If something does happen, what will we do? Just what we did before. We'll first log an error, failed to get stops for trip. In fact, we can even inject it here using that interpolation feature of C#6. And then we'll throw in the exception as well. And then we'll set the status code to bad request and return so that we're handling something correctly. Now let's go back up here and implement this get trip by name, add it to the interface, and therefore we will then be able to add it by using refactoring. So here's our method, and notice that the method that it generated for us is returning an object, and that's certainly not right. What we want it to return is a trip. So let's take a look at the interface so we can fix it there as well. And we'll just use the context again. We're going to include the stops because in our case, when we get the trip by name, we're going to need the stops. Well, you might have a couple of different methods on the repository for this instead, but I'm just going to include it for brevity. And then I'll add a where clause for name equals the trip name. And then I'll call for first or default so that it will attempt to return the first of the trips that match that, or a null if it fails. So back in our controller, we've now got our trip, and what we want to do is if the results equal null, so we couldn't find the trip, so there are no stops, just return JSON null. right? We don't need to return or map or do any of that. We're just going to return a null if the trip name wasn't found. Otherwise, we'll use the mapper. But in this case, what we actually want to map is the results.stops, right? What we're actually going to return, it ends up being the stop view model. And in fact, an enumerable stop view model. Of course, the stop view model doesn't exist yet, so we actually have to make that work as well. If we go down to our view models, let's add a new class called stop view model. And let's actually implement this. If you remember what our stop looks like, we're really talking about returning this part of the entity with this. We're not going to worry about actually returning the order in our case, but all the rest of this has usefulness to the client. So now we've got our stop view model, and at the same time, we can change the trip view model so that our view models will include these objects as well. But let's get the stop to work, and then we'll walk back briefly, and I'll just show you how that change to the trip view model will work. So back in our stop controller, make sure this namespace is being brought in. We should be to the point where we can actually get the stops for a particular trip. Almost. We can't forget about going here and creating another map for stop to stop view model. And now we'll reverse it as well because we're going to need to implement in both directions. Compile it all. And here in Postman, let's create a different URI. I'm going to say world trip as the name parameter, and then the word stops to show me the stops for it. And let's see if that works for us. See, we're now getting that full list of stops, but because of the nature of the way it looks here, it doesn't look like we're getting them in the right order. I happen to have been on this trip, so I know that Dresden wasn't first and Prague was second, etc. And because we're not including the order property, we're going to want to do the ordering before we return it. So let's make that last change. In the stop controller, we'll simply order them here. And what this will do is it'll do an inline sorting of it before it generates each of these view models. We could have also done it after the mapping, but I think before the mapping makes more sense. To compile that, execute it again, and we can see that now our trip starts with Atlanta, goes to Paris, Brussels, and Bruges, which is the correct order of the trip now. If we return back to that trip controller, you might remember from a few videos ago that when we mapped our getting of get all trips with stops here, that when we mapped it to the trip view model, it eliminated those stops because we didn't have a place to store them. There wasn't a property on the trip view model, which, if you remember from a few seconds ago, we had just added that. We now have a collection of view models, and let's see how it maps it between it. Let's come back over here and just go to the trips, and we'll see that now, because we've added this new property, we don't need to notify the mapper or anything. It's going to see that that new property exists when it does the startup of our application, and now we're seeing those stops embedded in the result as it returns it. So by adding those mappings and then adding those properties, all the mapping ends up cascading down through other types you have without having to necessarily tell the mapper that there is a relationship between them. The mapper finds a property of a type it knows how to map, it'll continue to map it. Now that we can get at our new stops, let's see what it looks like to add a new stop through the new stop controller.